Hello everyone, this is a new lessons. We finished last period about the permutations combination already, right? Now we go the new lesson probability. This lesson I think you guys used to learn before, I think in grade 10, right? But today we're gonna learn, we're gonna review and most of them we're gonna, teacher gonna let you guys, let everyone to practice more question, okay? So today we're going to start for the first definition first. First one, the probability theory. Second, experimental probability. And third, the theoretical probability. And in the third one here, I'm going to give you more example about for the probability of an event. And we'll talk more about the sample space and how to use the grid to find probability and more example about in the topic number 3. Okay, so we start for the first one first. Probability theory. Probability theory is the study of chance. Sometimes we call likelihood or events happening. You can see from the chart I gave here now. You can see from 0 to 1. That is the probability definition, right? So because event, you can see from event, if at the 0.5, this one means the probability of happening is a 50-50. That's we call equal chance of happening as not happenings. So that means can happen 50-50 or may not. Okay, the probability when you do experiment can be happen 50-50. And one here is certain. Certain that means 100%. 100%. That's like 100%. That means how to say? And even we have a 100% chance of happening. Okay, this one gonna assign as a probability of 1 or we can say this is a 100%. Okay, you compare with percentage. This one gonna be 100%. Okay, I use the same color here. This is gonna be 100%. Okay. And if at the opposite side here, 0%, that means impossible happening. Okay, that's represent with the probability of 0. That means 0 chance of happening for an event. And from the left, okay, the green color here from the left. From this one, you can see this percentage can be up to 75, 85, or 90, depend. Okay, but this one, if you close to this section, it means likely to happen, not likely to happen. And if to the right, because this on the left close to 0, right? So that's why we use the word not likely to happen. But when you close to the right hand side, close to the 100% or 1, we call this one likely to happen. And then this section, the red one, very likely to happen. That means really, really close to 1 or 100%. So the chance of happening is really have chance more, much happen. Have how to say, really likely to happen. And if on the left hand side, when you close to the 0% or impossible here. So this one in this section from the graph, we call is really unlikely to happen. Okay, this is an explanation for the probability theory. Is the study of the chance, or sometimes we call likelihood of each event happening, of events happening. Okay, so in this, so we can go for next. And actually, how to say? Actually, this one probability theory, most of time we can see is for the study of the theory of the chance. Okay, that is really important for some application like a physical and biological science. Okay, economics, politics, sport life insurance. The life insurance is a really clear example. Okay, or some like a QC, quality control, production planning in industry. So can use some with the many areas. Okay, like a life insurance is most clear to understand because the life insurance companies use this statistic on life expectancy and late, late, late in order to work out the premium, right? Without the premium who insure within their company. So if really young, you're gonna pay for the premium less, correct? If very high age, okay, you're gonna pay more. It depends on the chance or likelihood of the aging, right? If high age, that means high age, they will charge more premium, that's all. Okay, then they're gonna have some table like a what age from like a 5 years old up to 99 years old and how much they have to pay. And then use this one also, use the idea probability theories to adjust for the premium, which is customer have to pay for each for the life insurance. Okay, so now the next one, see the next one. This is about the idea of probability theories. Okay, so we go next one. The second one, the experimental probability. You can see this. I like for more meaning for the what the meaning of this one, experimental probability. Any happening for which the result is uncertain is called experiment. Okay, it's called experiment. Experiment sometimes it's like a trial, like you do in the laboratory or do some how to say, try to test or how to say, do the experiment. So this called experiment. We can say the number of trials is the total number of times the experiment is repeated. Okay, because sometimes when you do experiment, you have to try several times, right? So you have to count the total number of times when you do the trials. Okay, so that means you're gonna repeat again and again. Okay, for example, like maybe I give you this one example later, but then we see a definition first. And the next one said the possible results of the experiment are outcomes. Of course, result means the outcome. Okay, result means outcome, correct? Or sometimes we call sample space. Okay, for each experiment, we're gonna have the outcome or the result for each time. Okay, so then can say the outcome are the different results possible for one type of the experiment. Yeah, that's the one similar meaning here. So just give you more, describe more the meaning of the outcome or the sample space. Okay, then the frequency, this one. The frequencies of a particular outcome is the number of times that this outcome is observed. Okay, the frequency, that means how often. Particular outcome, that means each time you're gonna have one particular outcome. So this is a number of time, correct? This is a number of time of each experiments. This one is the one you're gonna observe and take a note when you do the experiment. So final, this one is the another definition. They're all related, okay? From this one, from the experimental probability, we can have the relation. The relative frequency of an outcome is the frequency of that outcome expressed as a fraction, okay? As a fraction or percentage of total number of trials. Okay. So you can see what the meaning here. So you can see example that can explain for this one at the final when we do each experiment. Okay. So that's for example. Okay. When a coin was tossed into the air 279 times, it landed heads up 183 times. So the relative frequency of this outcome, what gonna be? That's gonna be equal to experimental probability, the same meaning, right? So gonna be, you're gonna have, see this one, where the message, the number, the outcome are the different results possible of one triangle of the experiment. The frequency particular outcome is number of time that this outcome observed. So in this case, because when you're tossing in the air, like you keep tossing the coin, right? Was tossed it into 179 times. So this is a total, correct? But then the coins landed head up. So the result we can get the probability the experimental probability we have gonna be 183 over 279. So this is the answer for this example. That means you can get just say the formula like experimental probability. We equal to this one, the relative frequency. Okay. So actually that means the chance we get the probability of event over the probability of the total. Okay. That's the meaning when you do the experimental probability. That's the result you're gonna have. Okay, this means this one become P of if the coin landed with the head up. Okay, so that's an answer. Okay, so we go next one, an example. The third one, the theoretical probability means a particular event is the theoretical probability of a particular event is a measure of the chance. Okay, see this. It's a measure of the chance of that event occurring in any time of the experiment. Okay, so in this, just the past example, when talk about tossing the coin, how many? The land up 183 times, that's one. I mean, yes, from the total when you tossing it 279, that's the formula from there. Okay, so actually this formula of the probability of an event gonna equal to what? PE. PE means P probability of event equal to NE over NS. NE means the number of members of the event. And so we use this one, use the small the alphabet E. And this one use the S. Okay, the total number the total number of possible outcomes. So NE over NS. Okay. In other words, let's say the definition of this property of event. If any event E has NE, equally likely outcome. Equally likely means the outcome can be equally happen. Okay, and is some sample space S has S equally likely outcome, that the probability of the event E is this formula. So this one is a formula of probability. Okay, this is a formula. Okay, so I put this one down. This is a formula. Can I have enough space here? Yes. This is a formula probability. Okay, so we can see example of this one. Okay, so we can see how to use this formula, right? The probability formula. Like this one, if we consider the orthogonal spinor, orthogonal means have eight pentagon, right? Means each side should be equally. Okay, but my picture may not really equal. Should be equally, so that the chance gonna be more accurate. Have each piece, this one have to be equally. So have eight sizes. Say if say we want to find the property of find the property of the mark of the, how to say, if you want to find the property of the chance of gonna be happen for number 7, for example, like this. So this one gonna be, because we have, so 7 is only one, right? Maybe try number 8. And then because in this spinner have a, so the chance happen NE, right? This one become 1 because have only 1 8. But the whole thing we have 8, so become 1/8. So 1 is mean NE. The number of member of event, or the number of the experiment or the chance can be happen over NS. NS the total number of possible outcome. So this is a total 8. So because we have the 8 numbers, or have the S spin numbers. Okay, so this is the property of number 8. So if you want to count to be how many percentage of this one happen, right? So gonna be 1/8 times 100. So, and then equal to what? How many percent? How many percentage? So 100 divided by 8. So we have about exact to 12.5, right? Percent. Okay. If this will convert to be decimal, just say equal to 0.125. Okay. So that's how to use the formula of probability. Next example, A. We do question A first. 2 coins are tossed. What is the probability that both land head up? So 2 coins, you can see when you do the result or sample space. Okay, result sample space can be what, two coins, right? So you could have head, tail, and tail, head, right? And then tails. Okay, so this is S, and then E, the event happen is what? They need land up with the heads up, the coin heads up. So only one, correct? Only one can happen head to head. So this only one. From this one, when you use formula P head, right? The property of P head gonna be what? NE over NS. NE over NS. So we're gonna have had only one chance, so over 4. Okay, this is a question A. Then you see next one, question B. B, talk about card. Everyone know card, right? Playing card, the poker. Don't standard of playing card. What is the probability that it is A? This one is mean number A here. So the whole desk of the card here, how many total? We have 52, correct? Because everyone still remember the kind of card. We have 1, 2, 3, 4, 5, number, right? 6, 7, 8, 9, 10, and then go A should be this one, A. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and Jack, Queen, 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 King. So this is gonna have what? How many kind? Each card is kind of cards gonna have 4 kind, right? Gonna have like just see, let me draw here. Heart, right? We have heart, red one, and diamond, red. And what else we have? Maybe I use this one. This one cup, right? And then spread like a hard one and have. Okay, so we can see we have total 10, 11, 12, 13, right? So the whole thing gonna be what? Equal to 52. So each kind have 4 times 13. 13 times 4. So we have 52. 52. So the total desk cards of cards have 52 cards. But then they want to know what the property of that is an A. Okay. So in this case, we can, when talk about this, we can think about when you learn the combination, remember, we can use the combinations, right? So how many, the total, we have 52, and then C, we pick A, but have 5. Oh no, what the question? They need how A. So have this one maybe we use probability first. Don't use the combination. Sorry, come back here. So PE use a formula gonna be P of A, right? The card A here gonna be NE over NS. But for E, because A we have 4, right? 1, 2, 3, 4. So E gonna be 4, total 52. So become what? 4, 1, 4, 4, 1 over 13. So the property of the card A equal to this one. Okay. Okay, so we go next example. Next one, finding and sample space. Find the sample space for this one, should separate. For each the following, one coin is tossed, second 2 coins are tossed, really similar to period. 3 coins are tossed. Okay, that now I want to explain about sample space. Sample space sometimes can say outcomes or results, right? So sample space gonna have 3 kinds. First is the listing outcome. Okay, this one have 3 kinds. 1, listing outcome. Maybe I write down here. 1 is a listing outcome. Which is gonna do is here on this page. Second is two-dimensional grid or 2D. Right? And third one is tree diagram. Okay, so we try to see the first way to do is a listing outcome. If one coin is tossed, this one easy, right? So everyone know the sample space gonna be what? You can like listing mean this one. You can like in this way, become head, tail, right? You caught one coin. Okay. Then if B, question, this is a question A. Question B, if two coins are tossed. If you want to do by listing what we have, the sample space, two coin similar from previous gonna be head, head, right? Head, tail, tail, head, and tail, tail. So you listing the sample space by this way. Okay. If question C, three of them gonna be sample space gonna be head, head, right? And what? Head, head, tail. You keep lighting there, gonna be how many? Should be 8, right? Because 3. So 2 power 3 become 8. So you keep lighting up to you get the tail. But we can use tree diagram for this one. Maybe that's the next method. Okay, the next third one. So that's the way if we do by listing. So we light in this way. This is a listing outcome. Okay. So now we try the second one, 2D, two dimensional 2D grid, like the grid way. If we use the grid, right, two coin, if we do question example, this one, okay, by using grid, you can draw this one, like this one, right? Draw a line like this. Maybe it move here. Okay. So this one like a when you do in about function, when you draw the coordinate plane, right? This one like a y, right? And this one like a x axis. This is a y axis. But in this case, when you draw the grid, 2D, two-dimensional grid, so this is why you can represent, say this is a first coil, right? The coil number 1, you can say that. And this one, you can say this is a coil number 2. Okay. So, and then if this one, because each coil must have head and tail, right? So you can draw here head, and this one tail, head and tail. So this it will do by the two coils. Okay. Now from this one, you just put X first, right? The coil, the first, second coil here, gonna be this point. So this one represent head, head. And from this one gonna be tail, head. Lead X first, correct? And then this one head, right? And lead the Y, T. and then this one gonna be T, tail. Okay, so that's the way for this grid. So actually you should have one dot here. Should the dot represent dot here, and this one dot. Okay, so this the grid way how to plot graph by using the two-dimensional grids for two coils are tosses. Okay, see the next example is two six-sided dice are tossed. What is the probability that the total of the two dice is 7? If you want to use, you can use table also or use grid. So I do this one first. Actual up here. You can say this can draw use the table, can represent by table. So if you want, okay, it's a table. So this is a first dice, and this one second die. So you can see because two six sided dice, right? So dice have how many, have what number? 1 to 6, right? Have 1 to 6. So the first one should have number 1, number 2, 3, 4, 5, 6. Okay. So then the second one should be what? If you want to get the two dice is equal to 7. So the second one should be 6, right? And then this one should be 5 because 2, 5 becomes 7, and this one 4, 4, 3, 7, 4, 3, 7, and 5, 2, 6, 1. So if you do by table like this, okay, can do by this way also. Okay. But now if you want to use by the grid, this is the table. So we can do by here. You can draw to this one. One, because I have number 1 to 6, right? So you 1, 2, 3, 4, 5, 6, and then this one also 1, 2, 3, 4, 5, and 6. Then we draw this table, maybe easy to see. And this one. But when you draw by this grid table, it really helps me, because we can answer all the question. Not only say 5, only number 7, sum it up equal to 7 from the two dice. Okay. So then see this. If I use two color, okay, then you can see this one this one can say this first two dice, right? 2 6 dice. So this can be the first die. This one become the first die. And this side becomes second one. Second die, dice. Okay, so then you can like 1 1, right? So you have 1 here. And then go on 1 1, so 2 1. Depend, you can use this one first or first, but we this one first die we assign, so we like word first. So this one will come 3 1, 4 1, 5 1, and 6 1. Okay, and then this one gonna be 1 2, 1 2 1 3. We can write here, maybe easier. 1 4, 1 5, and 1 6. Then this one gonna be 2 2, 2 3, 2 4, 2 5, 2 6. And this one gonna be 3 2, 3 3, 3 4, and 3 5, 3 6. And then this one gonna be 4 2, 4 3, and go on. Okay, keep lighting. And then 4 4, 4 5, 4 6. This one gonna be 5 2, 5 3, 5 4, 5 5, 5 6. Also next 6 1 already, 6 2, 6 3, 6 4, 6 5, and 6 6. So how we gonna get the answer for the second example? Two 6-sided dice are tossed. What the probability of total of 2 dice is 7. That means sum it up, right? Sum it up and equal to 7. From this table, you can see sum it up to 7. Which one we can? 6 plus 1. This one okay, work correct. 5 2, 7, 4 3, 7, 3 4, 7, and 2. This one 2 5, 7 also, and 1 7. This exactly on diagonal here. Okay, I use yellow color here. Exact here. Diagonal line. So you just answer this one. So okay, sum equal to 7. So how many we have? You count 1 2 3 4 5 6. So the event E, the probability the change gonna happen is a 6. But S total how many? Because two dice, right? 2 6-sided dice. So become 6 become 36 times, right? 6 times 6 become 36. So then we have P of number 7 equal to 6 over 36. That means 1 over 6. That's a final answer for probability of the 2 dice sum it up equal to 7. So in this table, it's really useful, right? Because I can ask you another multiplication or subtraction. So in these 2 dices by using the 2-dimensional grids. Okay, so can we go next example? Okay. This one they can draw one line like this, very easy to see. Okay. Okay, so we go next example. Okay, the next one for the sample space. Sample space, we have three kind. One listed the outcome. Second, the 2D grids, right? And third one's the three diagrams. Three diagrams is really nice thing also, but it's sometimes if your experiment a lot, right? It's not proper because your tree gonna be really large. So it's a good for maximum 3 or 4 objects only when you want to test or do experiment to get the probabilities. Okay. So then if for the three diagrams, I will use, for example, if you want to find the two coins, okay, two coin tossed it. So if we say we do by the two coins, okay, are tossed it. So we do by the three diagram. So if two coins, right? So you can write down, say this one, this head tail, right? And this is the first coin. From this one, you can draw this one again. So this one is the second coin, have head tail. And this one also, this one the first coin gonna have head tail, okay? And this also head tail. So have two coins, okay? So you can get the sample space. From this one, sample space gonna be so head, right? You have head here. And then here head tail. And then tail head. And this one tail. So sample space, the total or Sn, this one equal to ns, correct? The total of the number of the experiments. So you have 4. So if they say want to get tail, so become 1/4, that's all. Okay. If three coins, how to do? The tree gonna be really large, right? So you just add more, that's all. Add another from here. Add one more like this, right? Head, tail. And this become the third coin. Okay, and this one also from this T, right? This arm gonna be HT, head, tail. And this one also head, tail. And then from this one, T gonna be head, tail. Okay, so sample space gonna be sample space. So you just lead head like this way. The first one gonna be head. And then also head and head, tail. I think this one everyone know already. You learned before last year with when you are grade 9 or 10. Okay, head, tail, and then go on. Head, tail, and then this one head, tail, head, right? Keep leading in that way. Okay, so I will leave this one. Let you try by yourself. So keep doing until you get the last arm become tails. Okay, and then you can get how many you can count, right? So because 3, so we can use the, when we learn, remember we learn the counting principle, right? So how many total we have, because head and tail, right? So base is 2. And because we have 3 coils, so become power 3. Like when you do 2-4 question last time, we learned counting principle. So the answer, this one should become out with the 8. The sample space, this one is what? NS. This is the NS. Okay, the total number of the experiment. And then depend what question gonna ask, how many, if they want two heads, so then you count, this is one chance, this another chance, and then you keep counting from there. Okay, so I skip this one because I think you learned before. But you can leave, we're gonna give you handout also. Okay, now next example. Okay, the next one. In Arizona, the pick game, and the player choose 6 different numbers from 1 to 44. If this 6 number match the 6 number draw in any order by the lottery, or this one talk about the lottery commission, the player wins or share to top prize. What is the probabilities of winning the top prize if the player buy only 1 ticket? Oh, this one buy only 1 ticket, very few chance, right? And the question that said in the lottery games, like when you buy lottery, they have 6 numbers, 6 different numbers. And how many number there? 1 from 1 to 44. Okay, this 6 number match the 6 number draw. So when they draw it, when you get the 6 numbers same, right, you can get a first prize. But I think it's really hard, right, if you buy only 1 ticket. So they want to find the probability of this. If you buy 1 ticket, the really chance may be 1 of how many million, correct? So then in this question, we can use what? Probability formula, right? So we have the formula is what? PE, probability of event, right? Event, and then equal to NE. NE is the number of the event that the probability, the chance gonna happen, over NS, the total number of the experiment. Okay, in this case, because you buy only 1 ticket, very few chance. Okay, so NE is a 1. So, but you have to find the NS, right? This NS, we can use the combination we learned, correct, from the last lessons. 44, because we have 1, we have this lottery have from 1 to 44. So can you, how many? So 44 numbers, correct, but they need to have the lottery only 6 numbers. So you can have 44, the total, right? C6, select or pick only 6 number from out of 44. Okay, so then you're gonna have 44 C6, then you use the last lesson you learn combinations. Okay, then this one you're gonna have, this is the NS. So you have 1 over 44 C6, and then you find, you can use a calculator. Okay, maybe we can try from here. This one, just how to say, review the formula. Combination is what? NCR, N factorial over N minus R factorial, right? Times R factorial. So this one gonna be 44 factorial over 44 minus 6 and then times 6 factorial also, and then times 6 factorial. Then you can use calculator if you want. It's okay for this case. So 44 factorial over 44 minus 6, what we left? 38 or not? Yes. Then you can simplify. So we have 38 factorial times 6 factorial. Then if you simplify by manual, right, what we have to remember, 44 times 43 times 42 times 41 times 40 times 39 times 38 factorial, okay? Then we stop like that because we can cancel with the denominator 38 factorial times 6 factorial. So this one cancel. So you left the top. 6 factorial means 6 times 5 times 4 times 3 times 1. Or you use calculator right away. So if we use calculator, this one gonna be really large. If I use calculator now, 44C, 44C6, right? 44C6 equal to just, that means all this number type it up and divided by 6 times 5 times 4 times 3 times 1. So we have 7,059,052. Yeah. 7,059,052. Oh, that really large. You see, so final become 1 over this. So what the property you can have? Very few chance to get a prize, right? So don't buy lottery. No good, no good. Don't play lottery. Unless you are really, really lucky, okay? Okay, so then you just leave the way, or you can divide, but I don't know gonna be what 0.00 something, right? Really few chance. So we can use leave in the way. Okay. Now, next example, hopefully gonna be last one. This one. You see the US maps. I'm not good drawing, okay, but just approximate only for this question. Okay, so really not the X same as the correct one, okay, this approximate, just only need the number and how to look like approximately. Okay, now this example, the numbers of college and universities in various regions of the United States in 2007. I'm missing something here. Okay, that's correct. Are shown in the figure below here. One, the institution is selected at random. What is the probability that the institution is in one of the 3 southern regions? They need this one. 3 southern regions. So that means you see the map here, the figure here, right? This is a US map, okay? East region, like this mountain, they have 303 college and university, and West North Central 450, East Northern Central 660, New England 264, and Middle Atlantic 629, and South Atlantic 738. And this one is South Central 276, West South Central 406. Okay, but question 1, you find the property of this one. Of 3 southern regions only. What is the property of the 3 southern regions of the college, the number college and university? Then you have to use a formula, right? PE, probability of, is the property of PE, the probability of event, equal to NE over NS again, NS. So E is this three, correct? Because question 1, 3 southern regions. So you're looking for this one at the south part. This one not west, east, and not this one. Middle Atlantic, south now here. So is this one, the blue one here. This one, correct? The blue one here. And the pink here. Because it's the southern part, the other one. This is the southern part. And this is the southern part here. And also the purple one, purple color here is the southern part. So you get these three, 1, 2, 3 exact, 3 southern regions. So that is E, right? So we can write down the result of this one. So E is a number of events, okay? What we have, the blue one, 738 plus 276. I mean this one, okay, the pink one, and the west south central is what, 406. Then divided or NS. That means you have to sum all this information we have. This is a NS, total number of the experiment. That means that all the data we have here. So become 303 plus 450 plus 660 here. I get from here, okay? Get all the numbers, sum it up. Plus 264 plus this is a divide, okay? 264 plus 629, and then also plus 738 plus 276 plus 406. So the bottom, this one denominator, okay, is a NS and the top is a NE. And then you just sum the top, what gonna be? Okay, so 738 plus 276. Maybe I'll let you do this one, right? Because just tell you how to do that step. Okay, just finish 378 plus 276 plus 406. The top gonna be the NE, right? Gonna be 1420 divided by the bottom one where we have sum all up 303, sum all this one, sum all it up 3 plus 303 plus 450 plus 660 plus 264 plus 629 plus 738 plus 276 plus 406. Ooh, 3,726. That's the answer for the poverty of this institution in one of the three of these three south part regions. Okay, that's the answer. Then you can use calculator and find out the decimal or whatever to be the final answer. Okay, just approximate it up, become the final answer. Maybe get the 3 decimal points. Okay. Okay, so now this is the probability for today. Okay, and they will give you handout, and then you can practice some question. So my plan gonna finish these lessons probably this week or next week. Should be the last week. This week or next week should be the last week for the or the lesson for the midterm. Okay, that means it is the semester to term 1. After this probability, we're gonna go the term 2 of for the second semester, for the semester 2. Okay. Okay, so that's all for today. See you. Bye bye.